Hello, everyone. Welcome to the Deployed Engineer podcast channel. I'm your host, Baulik. And today on the podcast, we have Michael Vandi. I really want to do this podcast. He is the founder of Addy AI, and he was previously a software engineer at Amazon Web Services. And he also did a master's from Carnegie Mellon University. He's an engineer that I have worked with. He's a CEO, but he has great technical acumen, great knowledge on AI, and probably one of the best software engineers I know. So today I really want to break his brain and understand like his point of view and his angle on where the whole industry is going and his perspective on these different topics, emerging topics we have today in the fast moving space of artificial intelligence generally and software and building a business around it. Yeah, let's get started here. Okay, Michael. So, is there anything else you'd like to add on to that? I think.
Man, that's a heavy weight. That's a heavy weight to carry for the rest of the pod. But I'm excited to be here.
Great. Yeah, walk us through your journey a little bit. Like, you are software engineer previously, you decide you're an engineer, you decide to start a company in the AI space. Like, how did you get started? And like, did you have an initial idea? And like, how did you pivot in? And so if you could give us an idea about that.
Yeah. So Addy AI was actually never meant to be a company. Like it didn't start off with the idea of it being a company. I was always one of those people who would build a lot of projects, and some projects would fail, some projects would do well on the internet. So I remember back in undergrad, we built this COVID-19 contact tracing app that did really well. We won the Maryland hackathon for it. And then I was working on some sort of like NASA suits project that did really well. We got to the finalists of the NASA suits project. So I was always building like random ideas every now and then. And I remember in 2022, ChatGPT had just come out and I was trying a bunch of different random ideas. And one of the random ideas was I suck at emails. So I was building this AI to help me write emails. So I had this YouTube channel at the time. I opened up YouTube streaming building this AI email writer. This was literally maybe like a week after ChatGPT came out. I'm like, hey, this would be good for writing my emails because I suck at writing emails. So I spent like 15 hours live streaming, building the code and walking with the community through it. And then I posted it on Twitter after it was built. So posted it on Firebase and built a Chrome extension, posted it on Twitter after it was built, went to sleep, didn't think much about it. I wake up the next day and my phone's blowing up. So I'm getting all these messages. And it turned out that what had happened was the Chrome extension had gone viral on Twitter because I posted this short 30-second video of it writing my emails, and people started signing up for it. And we did not even have the info for people to sign up for it. So folks started going on the website, so quickly whipped up a landing page and then built a wait list. So let people on. So the first week, I think we got like 10,000 people that signed up for the product, and then used that initial 10,000 people to then create the entire like authentication flow so people can then use it. So that was the first version of Addy AI, where it was just a simple Chrome extension that would respond to your emails for you. I was still in grad school at the time. So we built that. Well, I'm in the company, but it was only me in the company at the time. And then since I was still in grad school, I had 6 months left of grad school. So what I was doing was I was just maintaining the product. I wasn't even, working much about it. Carnegie Mellon's a very demanding school. So every now and then I'll just publish like an update here and there. And so folks started using it. I think at the end of my grad school education at CMU, we had grown to a little over 20,000, maybe even 30,000 users. And then I had a lot of ideas on what to build after grad schools. Because I was talking to users, I was getting a lot of feedback from users. I had a list of their pain points and their feedback, and I was like, I'll just explore one of these ideas. So I applied to CMU's Startup Accelerator, eventually got some funding to go for like a couple months and try to build something. And so I decided to do it.
Well, that's a great story. And so that from there on, like, what really inspired you? And like, you felt like, okay, like we need to go and automate and like make a difference in the loan origination and the whole like mortgage industry. How did you just like find that issue? And like, as an engineer, how did you like think about that problem?
Yeah. I mean, it's always been like signals around market signals. So the whole like email thing, the first day it was launched, like after I went back to bed, like woke up, I was hiking, and then when I came back from hiking, when my phone was blowing up, a couple of people that had retweeted it were Elon Musk, Vinod Khosla, and then they were saying that, hey, this is where the industry is going to go in like a couple of years, and now we see it now. Everyone's using AI to write their emails. So this was like the preamble to that. So the market had some sort of like insight on where the industry was going to go, and I literally just built for that. And so with mortgage loan origination, one of the ideas I had to pivot Addy to after, because there's a lot of competition in the email space. Actually, it was low barrier to entry, lots of Chrome extensions that were doing pretty much the same thing, but the emails were not personalized at all. So the number one feedback that users gave was that the emails were not personalized. So I thought, well, we could just build a fine tuning library to personalize the emails for every user. So that was the idea that I had, and then built this training library called Slang Drive. And then the fine tuning space also became heavily competitive. A lot of companies were building like fine tuning engines. But one of the industries that I was looking at was mortgages. And how we came to find about mortgages is went back to the original email assistant and then looked at the most active users and sorted them in descending order of frequency of which industry they came from. And I think e-commerce was one of the biggest industries. Consulting was also there. We also have logistics. And then number 4 was financial services, mortgages, loan officers. So literally you went, industry by industry, talking to different users and saying, hey, what do you love about Addy? What is it really helping you in your process? So for e-commerce, it was for customer support. So also tried building a customer support company for e-commerce. That space also became competitive. And I tried building something for consultancy and all those different things. Also became competitive. But once we went to the mortgage market, it became clear that they were using us to automate their responses to their borrowers and also just to help process loans faster. So got a lot of feedback from them, took a lot of requirements, and decided to build an MVP. So our first enterprise customer was this one special situation lender in Tennessee that took a bet on us and were like, hey, you guys can build something for us. So we built it for them. We shadowed their loan officers. But when we built it for them, it sounded like it was rocket science. They really loved what we were doing. So we asked them, what more can we do for you? They told us a bunch of different requirements that they had, and we just went ahead and built it.
That's super cool. How did you go about like building the extension? Like what kind of like APIs were you using initially, and how did you figure out, okay, like this is the minimum I want to do to satisfy these users? Was you'd keep building and building, and as engineers we tend to like overbuild things and and expect people to use it. Like how did you like control that urge, like keep building and like in the same space, right? You could have easily just been like so persistent about just building that one thing. And what is your feedback cycle like early on when you're working? And I think this will help a lot of engineers understand where they need to stop and like when they need to switch into like a more feedback hat, like get that feedback. Like what's your framework for that?
I think we've all fallen into the loop of building and overbuilding, especially as engineers. We think we can build everything. So the Chrome extension, the very first version of that Chrome extension, like the minimum viable product, that feature, which is just like press one button and then it responds to an email for you. It's sort of like it pre-selects a tone. So an email comes in, it reads the email, understands the sentiment, pre-selects a tone for you, and just click reply, and boom, it writes down the response for you. We later evolved into it providing like some suggested responses, and then it would write the response. But people still use that feature and still pay for it almost 3 years later. So this was late 2022, 2.5 years later, people still use that feature. And that's one of the things I'm coming to learn is not like overbuilding things. And the first version was actually very, very scrappy. I remember there were no inference APIs for GPT 3.5, which was the best model at the time. There were some inference APIs for some models like BERT. I think GPT-3 was like invite only. So like some companies like Jasper AI and Copy AI, they had APIs for that. But GPT 3.5 was meaningfully better than GPT-3. And I think GPT 3.5 the API only launched in March 2023. So for the first 3 months, there were no API. So what I did was build this sort of like Puppeteer browser engine that would create a bunch of I created a bunch of Gmail accounts, sign up for a bunch of ChatGPT accounts, and then I would literally route user requests to one Windows laptop that was in my kitchen in Mountain View. So that laptop was literally always on. And then once a request comes in, it would open up one of the ChatGPT accounts, log in with one of the emails that I had created, and then send the request that the user had requested. So I could literally see it like writing and then get the response back and then send it back to the endpoints and then send it back to the Chrome extension so users could get the responses. So when you click write an email, it would probably take like 30 seconds or like 45 seconds so you see the response back. So it was very, very slow. So that's how the first version was built. Like there were no API endpoints, and then later on, OpenAI launched their API endpoints. But there was so many different inefficiencies. OpenAI sort of like started launching captchas, so it had to solve for that capture problem. But for the first 3 months, there were no API endpoints. I literally had this one laptop, which I still have today in my kitchen, that I always had to keep on, and that was the very first web server for Addy AI.
It's super interesting, like the engineering angle on that, because most people wouldn't even think about like, okay, how, because you already have a barrier by not having an API, and you just like sort of found a way. Like, how do you think about like, a lot of times as engineers we try to solve a problem, and like this build bottleneck. But one thing I've noticed about you, Michael, is that you never take no for an answer. Like, that there's a way out. Like, what's your like what are some how do you think about such a problem? Like, how do you think about the technical challenges? Like, do you do a lot of research? And sometimes it's like, having a certain frame of mind that something can be done, and not just done, but within a certain frame of time, because you sometimes have to also learn and then build it out. So how do you like go about your process of like writing something like that? Like, how does it look like? Do you write a spec talk, like, okay, this is what I want, and sort of like go to the drawing board and do it, and keep yourself accountable? And like, when do you stop? When do you change? Like, just curious to know.
That's a good question. I think generally for engineering, the tools do exist, and it's like how you orchestrate the tools. And in a sense, we were kind of forced to build the product because we had like a database of 10,000 people that had signed up, and then they'd seen this demo on Twitter, now X, and then you just had to build a product. Like, I feel like this is like a continuing theme of the life as a company, because you say, hey, this can be done. We've built a prototype. And then people sign up and they're like, holy shit, now I have to go build it. And so with things like that, so no spec docs, have to launch really, really fast. So the tech stack for that was ngrok already existed, Puppeteer already existed, and then the automation to sort of like go on the browser, like select certain elements, they already existed. Like, what did not exist was this whole captcha thing. And also, I didn't have money to like automate like a Puppeteer browser living on the cloud somewhere. I had an old laptop that I had to always plug on, that, you needed to have like internet always on and all those things. So with general like software engineering principles, I really think that there are some tools that already exist. It's just like orchestrating the tools together. And then for CAPTCHA, there's literally this Pakistani company. I think they have a bunch of people. I don't know if it's a Pakistani company, but it's called 2CAPTCHA. And what they would do is you would install the 2CAPTCHA library. And so if you had to solve the CAPTCHA in Puppeteer, they would then send that CAPTCHA to sweatshops in Pakistan that would then solve that CAPTCHA for you using the same sort of like cookies and stuff, and then bypass that CAPTCHA. So we made sure to like give them limited access, of course, and everything. But it's all these different hoops that you have to go through, and then you just have to build the thing. And for me, it's just like fun, just orchestrating these different tools and then building the thing. But then it becomes a way where you're hanging on a very thin infra thread, whereas like anything could go wrong. So like I was
Yeah.
getting paged like every day, multiple times a day, of like maybe a captcha wasn't working. I think I built this chart of like success rates of API requests that would go through, like email requests that would go through. And I think like 30% of all of the email requests failed, actually. So if you click like write an email, reply to an email, like 7 times out of 10 it would go through, and 3 times it would not work at all. But then it was just fun to build. So I know I didn't answer your question like directly, but I think like the way I think about these things is like the tools exist. You just have to like orchestrate the tools to make it possible.
That's yeah, that's very interesting. Like how you sort of thought about it. Yeah, I think just like having it's like almost like having a chessboard and knowing where to place the pieces. I think that in itself is a skill of a good engineer because we don't typically like engineer everything from scratch. Like we don't really write the assembler and then go to C. We typically use this existing things. And a lot of value comes from like combining all this, all these pieces together. And that's interesting. So in terms of like some of your workflows, like, it's fascinating. You still, despite doing all these other roles, you're still very hands-on with coding. I see you writing a lot of features, when we're working together, and you have a great eye also for design, I feel like. So how has like AI sort of how has AI played a role like of late when it comes to some of your workflows? Here at Addy, like we use cursor, for instance, and we have unlimited cursor to write our code. Each one of us has a sort of a variation of workflow. What is your sort of workflow currently with the AI tooling, and how have you used this to make your life easier and faster? And when you have so many things to do and you're pushing yourself to build features as well.
Yeah. I also want to give you credit for, providing some of the AI efficiency on the team. So we started using Cursor more heavily when you joined. I remember when you joined, you literally did like a Cursor workshop with the engineers and with me. So you sort of introduced me to actively using some of these coding tools. I was using GitHub Copilot and some other coding tools. I was also copying and pasting code into Chat. But now we're heavily utilizing AI. I think like we max out our number of requests. I was checking our Cursor dashboard the other day. We max out all of those different requests. So the way I use AI is a little unconventional in the sense that I try to not only use AI for coding, but in every single thing in my life. So I have a UX GPT, which is I give it it was like a GPT where I give it like a couple statements about some sort of like UX problem that I have, and it would give me like copywriting examples. I built like a LinkedIn post writer GPT where I literally went on the LinkedIn's of different people that I love how they write. I took a screenshot. So LinkedIn, you could actually just like keep scrolling, like infinite scroll on LinkedIn, people's LinkedIn. And then I took screenshots of their last 100 posts and then put it in a PDF file. I did it for like maybe 10 people and then made a custom GPT for it. So now whenever I have a LinkedIn draft idea, I just put in that custom GPT and it sends back a response for me. So I sort of built like these micro GPTs for different things in my life. And I have always enjoyed writing code. So what I do is for Cursor now, I write a lot of, I would say I'm more of a sales engineer now than a software engineer that sort of like own end to end a particular feature because I cannot like own end to end a particular feature now. I've given that over to like engineers who can go very deep on it. But what happens is I would be talking to a customer and then they would mention something that they want. And I'm like, well, I can prototype this in a couple of hours and then put it on the platform, build like a V1 of it. And then eventually one of our engineers would go ahead and perfect it and make it better. So sort of like this sales engineer role. So for instance, the other day I was building this sort of like widgets homepage feature where we have these lead capture widgets on the product, but then they needed to be embedded on someone's website. And the customer was saying, well, hey, this would be cool if I don't have a website and I could still have this homepage where you guys host it for me. So I used Cursor to build this sort of like widget homepage, like a V1 of it. Took like a couple of hours and then launched it and then try to see how people would use it and then eventually would go into the product. So my coding role has now more evolved into being more of a sales engineer than a core software engineer.
That's a great insight. This way you could run like a lot of experiments as well and get feedback from people. Yeah, that's a good way to leverage some of these tools, I think. And so like just as a side note, like when did you like start writing software, and like what was like one of your first fun products? All this pre-AI, like what was sort of like your first sort of thing you wrote, and like how do you get into this space early on?
Man, that's a loaded question because I have a couple, but I distinctly remember a few that would be contenders for my first project. So officially, I started writing code when I was like 14, but unofficially like 7, because I got my first laptop when I was 7 years old. And then so you have these like block coding languages when that you could use. They were not quite coding languages in the sense that not like Python, or it's just like different blocks that you could, you know, code with. So if you're a 7 year old and then you can build like simple things with those block coding languages, of course, it's something like that. But I grew up in Freetown, Sierra Leone, which is like in West Africa, where like coding was really not a thing in my world. Like I like to joke that I might have been the only kid in the neighborhood with a laptop, but my mom was just like forward thinking, and a couple of different things. You and I were talking earlier. A couple of different things happened earlier in my life that made me a software engineer now. And I could think of 3 instances. So my mom had this one friend that was a lawyer. And then at the time, I had just come home from school in first grade. And I came home, he was home. And you know, like when you're growing up, people ask you, oh, what do you want to become? Right. And then I was like maybe 5 years old at the time. And he was like, oh, you should be an IT person. You know, I was like, oh, IT sounds cool, because he knew that I from when I was very young, I was playing with like a lot of electronics. So when he came home, he saw that we didn't have electricity abundantly in Sierra Leone. So I would get these like LED lights, and then I would, you know, connect different cables and then get these lithium ion batteries, and then sort of build a casing for it and then build it for neighbors actually. So I love like building these LED lights. Like it would be rechargeable. You know, it would also be like you would just get batteries off of the store, and it we just so I became known for like those kinds of projects. And then I would get scraps and just build these electronic things. And then he said, you should be an IT person. He didn't quite say software engineer. So I sort of like knew about IT and all of those things. And then when I was 7, my mom got a job. So that's the second instance. The second instance, when I was 7, my mom got a job at a NGO called Care International. And then, which means she had a laptop, an official laptop that she would come home with. And so she would print all these like Yahoo articles, you know, like when you go on the Yahoo homepage, there's like a bunch of articles. So she'd print them for me. But then she taught me how to use the internet. So a 7 year old kid with the internet, I was lucky enough to stumble upon coding and building apps instead of other things on the internet. And so I started looking a bit into that. And then I think the third thing that happened was my aunt gave me this sort of like toy laptop when I was at that same time when I had my own laptop. This is when I learned how to use all these like block coding languages. So those 3 things sort of like orchestrated, if you will, my love for software and coding. And so I took like maybe a little bit of a break until like I was 14. Another thing what happened was Ebola. So we had the Ebola epidemic in Sierra Leone in 2014. And what happened was I had all of school shut down. I had all this time now. The school shut down for like 18 months. I had all this time to then just play around with the computer and write code. So I stumbled upon Android Studio again, revived my love for coding, learned how to use Android Studio, and I built this sort of like game. I literally just like downloaded the binary, like not the binary, the like APK file, and then you could like unzip the APK file like Android Studio, and then you could change. I changed. It was like a helicopter game, and I changed the background of the helicopter game to just be like a background of Freetown, because I was hoping that when school reopens, I was going to show that to my high school friends and their minds would be blown. So I literally just changed that one background PNG file and then showed it to my friends, and they were mind blown. And I just became known for like this software guy. And then because I didn't have access to much hardware with software, all I needed was a laptop to build a couple of things. I was probably bullied a little bit because people didn't understand like what technology was. But then, you know, I had a social media account then, so started looking up things about like Adam D'Angelo and all these different people. I literally sent like Adam D'Angelo an email when I was 14. I was like, hey, can I come work
Wow,
for you?
that's crazy.
I did.
Okay.
And yeah, that was sort of like my start to computer science. I went to college, but by the time I was in college, I already knew like Java, I knew Python, I knew other things. And you did ask, the second part of your question was what was my first program? I think that helicopter game, if it counts, of just changing that one image file. Yes, if it doesn't count, then it was this C++ game that would determine whether or not you can drink alcohol. So you enter your age, And then it was this little if else statement. So it's like if you're over 18, it prints out, hey, you can drink alcohol. If you're under 18, it prints out you cannot drink alcohol. So yeah.
And that's interesting. It's great. You had a good start and like you really had a strong interest from early on. Now, let's say that you are now, 14. How will you go about learning programming? Is there something you've changed given that now we have this we have Chat GPT and we have all these newer sort of systems, fundamental shift in the way people can learn, the way people can plan, or the way people can, or the level of things people can do now. So how would you like go about it? Like let's say like from you just 14 again, and you're like looking you want to build stuff. Now you have this technology at your disposal. How will you go about it?
I think there's a huge disadvantage with people who are trying to learn how to code for the first time. Disadvantage in learning the basics, but an advantage in how fast they can get things built. So I do think the basics are important. So with what I know now, if I would start to learn how to code, and first of all, like what coding teaches you is just it teaches you how to think. So if you look at what a code base is, like the anatomy of a code base, you have all these, let's say the most basic computer program, well, let's say a simple Android app, would probably have like 20 files, and each of those files, they belong to different folders. And then, you have different classes and objects and how they relate to each other. And you sort of have to sort of like maintain a mind map, like context of how all these things relate to each other. So if you change one file, you have to know that, hey, it changes in another file. So sort of having that sort of like mental model on how to think, I think it helps. But with the way coding is being done now with all of these AI tools, whereas you can go to Lovable and then say, build me an Android app that would, keep all of my recipes and then generate all the files. Now you suddenly don't have access to that context of what the different files. You wouldn't even probably know the file names, right? So if I was to start now, what I will do is learn the basics I would learn the basics of some sort of like computer science algorithms. I'd learn, for instance, I'd learn data structures. I wouldn't spend too much time on it. I would learn like basic control flows. So I'd learn like sequential statements. I'd learn loops. I'd learn like if else statements. I won't spend too much time on it. And then I would actually use the AI tools to then, after it has generated the code, let's say I say, hey, generate me a code base for an app that keep tracks of all my recipes. And after it's done that, and I can also prompt it, explain to me how you did this and walk me step by step through every file, what different things mean. I think with that, it sort of like blends in the association, but I think you're always gonna miss that sort of like first principles association of the thing. So maybe coding will fundamentally just change, whereas people don't have that first principles associations of all the different files, but they definitely do need to know like the basics of what a class is, what an object is, all those like different things in order to prompt the technology better. So I will use AI to explain the code to me after it has generated the code. I think that's probably one of the best bets, if not, going to software engineering education and then just like studying basic data structures and some sort of like computer science materials.
Oh, that's interesting. So one of the things you're recommending is people should not just outsource everything, to AI, but they should develop some of those critical skills, right, to sort of learn and build these things. There's this take from a lot of leaders about AI replacing software engineering in the next, I don't know, maybe 5 years, and like fully using natural language to do this work. Like, what's your sort of as an engineer previously and now as a founder and who is working this space and having experienced these tools firsthand and leveraging them, like what is your personal take on like where this might go in the sense of like would we have like a fundamentally different role when it comes to engineering? Like would we all like just be prompting natural language and then having the code like being written under the hood by this AI system? Do you still think like there's some level of value in like going deep into something and learning how to like handwrite maybe some piece of software and like understand it? What's your take? Like would somebody like how would you think about it? Let's say like given there's all this uncertainty and you're like is it even worth learning this thing? Like if
Yeah.
someone had to go down and read a Next.js document right now, but AI can do it very quickly, very fast, right? Where do you draw the line?
Yeah. I will answer that question based on what we're doing now and how the industry is, because I don't have a crystal ball to know like how it's going to be in like 5 years. But based on what we're doing now, I would advise people to learn how to code, because learning how to code is not only to build apps and, to become an entrepreneur and whatnot. It really is just teaching you how to think. So we have to decouple knowing how to code from the outcome of building software, because you necessarily don't need to know how to code now to build software, but learning how to code would help you think. And so that's a decoupling that we have to, first of all, so once we've done that decoupling, and I think then learning how to code now is just not enough. It's just one thing that you need in order to provide more value in an organization. So we'll see the rise of more sort of like niche roles in software engineering. So the role of a software engineer would now be more of like a forward deployed engineer, where they spend not 100% of their time writing code, but more time interfacing with customers, more time gathering requirements, more time sort of like running their own mini startup within an organization, especially in the B2B context. For our roles at Addy AI, all of our engineers manage a couple of customers where they get the requirements. They're literally running their own startups inside of the company. And 100% of the time, it's not spent writing code. It's spent maintaining customer relationships and then helping to grow the business. So once we decouple the meaning of coding to being like the output of being a software engineer, then we start creating space where software engineers can learn new skill sets, like being more forward deployed. And then once we have that, right now, even at Addy, we're not hiring junior engineers because we think the market has just not shifted to being as effective to the skill sets that we need right now. So every senior engineer on our team, experienced engineer, has Cursor as their junior engineer. They have Lovable. They have all these different tools that sort of like serve as their junior engineer. So generally, I think it just has to be like a mindset shift of the industry and saying engineers are not going to be replaced. Junior engineers, there won't be a need for junior engineers on the team, but there would be a need for people who can prompt code and then achieve some sort of like business metric. Maybe that's being in front of customers. Maybe that's even being like some sort of like customer support or some sort of like sales role. But the solo engineer, I don't think we will ever get to the world where there's a solo engineer that spends 100% of their time just writing code. Like that world is dead. Like solo engineers are dead. We're never going to be in that world again. But there's also a world where there will be some interest in research. So, and this is going to be like a small fraction of people who would be responsible for doing research and then maintaining existing code. I think there's going to be a huge need for maintaining existing code in a sense that programming languages like Rust, and this would be a very small percentage of software engineers where they know very deep about a particular programming language like Rust, and then they're just maintaining that programming language. They don't need to like know AI or anything. They just need to know, because like if AI generates Rust code, you need people that can maintain the Rust programming language, to make sure that it's good. So I think there'll be three classes of engineers. There'll be researchers. There'll be engineers that provide some sort of business value, and then there will be maintenance engineers that maintain existing code infrastructure.
Oh, that's a great insight on like what the roles might change into. I like the detail on that. Relating to that, when these roles are changing, it implies that the one of the skills that a person would have in such a role that's very critical is communication, like good communication. What are some things that a person who is trying to evolve into this new role? What are some of the skills they should develop, and like what kind of, are there any books, or are there any like methods that you used personally to improve your communication skills, and or any recommendations you have for people to be able to balance this? Because there's a stereotype where a lot of technical people are tempted to go into jargon, and I'm also like guilty of that. I have to hold back all my knowledge like before a dam, because most of the times you don't, the person you're talking to, like a customer, doesn't really understand what an HTTP request, or like what an XML request is, right? Or that's all they care about is why this button not working, right? So what's your, how do you communicate? Like how do you just general outlines, like how do you deal with, like how should an engineer promise, for example, a feature? How much should they promise it? Like, any guidelines on things like that?
Dude, I'm CC'd in some of the emails that our engineers send to customers, and I'm always prompted to write some sort of like customer translation AI that will just translate all the engineering jargon until I'm like, whoa, this is a very technical email that you're sending to this person talking about like APIs and like document processing. I think it's just doing it. And I don't think there's a non cliche answer to this, but we've all been there. Even me, when I first started, it took a couple of customer communications and them asking, "Oh, what is that? What?" Until I say, "Well, I'm just going to communicate the business value to you," in a sense that we all have something that we know a lot about, and that becomes a disadvantage in dumbing it down to explain it to someone who knows nothing about something. So I see it as, like when you have kids. I don't have kids, by the way, but I grew up in a family where there's kids around. But they would ask you, like, hey, why is the sky blue? Or some sort of like very mundane thing that should have a very simple explanation. But if a kid asks you, like, why is the sky blue? Whoa, there's a lot of, chemical and the rays of the sun, and then hits the atmosphere and all of these different things that you would have to explain to them. And if I'm a, let's say, astrophysicist, and then someone asks me why is the sky blue, I am prompted to explain all of the different like astrophysics things. But what I think is what needs to happen is the engineer needs to work in the perspective of the person asking the question so that they can understand the lingo that they need to explain it to them. Because it's not like we don't know how to explain why is the sky blue. We just don't know the lingo that will translate well for them. So in the industry that we work in, for instance, if we do a lot of like document processing and loan processing. So if an engineer is talking to a customer that then asks, for instance, when is this document processing feature gonna launch? And then you have to explain to the loan officer by promising, a specific roadmap. You can't start by saying, well, first I am gonna build an API endpoint that will extract OCR data and then extract OCR data, send it to an LLM, and then do this and do that. So if the forward deployed AI engineer knows the role of a loan officer and has sort of like worked in that role before in a sense that they understand the lingo, they will be able to explain it in a sense that, say, how can I translate when is this document processing feature going to come along? I would say, well, first of all, we have to connect to your LOS, ingest all of your loan docs. People call it loan files. And then so I would say the first thing we do is connect to your LOS, ingest all of your loan docs, and then we will connect to some sort of like AUS findings and then do it. So like use the lingo that they use. And I think that's what's missing. It's not like engineers don't know how to translate it. They just don't know the lingo that they use. And you can only know the lingo if you have worked in that industry.
Oh, it's like putting yourself in the shoes of the other person and trying to understand, like it's almost like understanding a new language that people speak, and then trying to at least mimic that and get to and so that they feel like, oh, he's one of our own, like almost something like that, even though
One
it's the
of our
same
own.
language. Yeah, it's one of our own, like like because engineers love talking to other engineers in the same language. And I think similarly, I think if like somebody is like a business person in, let's say, loan origination space, knowing what these different acronyms mean kind of make them feel like you're on the same ground. So I feel like I like that point of view. For a lot of people trying to break in this space, like they do not have a practice ground, right? Like, for instance, I'm a senior engineer and I have the ability to, yeah, I've had experience talking to people, and like I've had some practice ground with customers and things and side projects which I've sold and whatnot. So I've had that practice ground. How should a new person get this practice ground for communication? For instance, when it comes to an application or coding, your practice ground is just your laptop, right? But with communication, you have to build a practice ground. What is your maybe how would you do it, for instance?
Yeah. There has to be some sort of executive decision that allows for training of engineers in the niche that they work in. So you and I have talked about this, and this is one of the things that you have recommended a whole lot on the teams. Like, hey, we should all just get our loan officer licenses, right? Just so the company has to say, well, we're going to take 2 weeks where all the engineers study to get their loan officer licenses. I think it only works if there has to be some sort of like executive level buy-in and says, hey, we're going to train our engineers. Because if I'm an engineer and say, hey, where do I start? And I don't have a job yet, I would not say, well, I'm going to go get a loan officer license because I want to work in lending. I'll first look for a job in lending and hope that job in lending provides the training program that allows me to get my loan officer license, right? So the responsibility is almost like entirely on the company to create that training program for the engineers. And if you are an engineer at the company, I think you should be pushing your executive team to say, hey, we're working in insurance. Can we get some insurance certification? Just keep pushing, pushing, pushing that for it to happen. And if you're doing like an interview with a company, you have to ask them about all those things. And once companies start maybe hiring junior engineers that they train, I think all junior engineers should just be pushing their executive team to sort of like having those training programs available.
So I think that's a great way to, yeah, the training, right? That's as simple as that. Like it just makes so much sense. Hopefully, like, more companies will kind of understand this and break those silos and understand that, yeah, that's the rule, is evolving, because there's a lot of legacy systems, and I think with time, this, I think this will be like a norm. That's yeah, it does
I hope
seem like it. Yeah. So like, let's say, fast forward 10 years, like give us you're to write a novel. Let's say you're gonna write a novel, right, by Michael Vandi, like, and like 10 years down the road. What do you picture? Like, what would an engineer do? Like, just think about where your mind can take you. You're writing a novel. So like, what would be things look like? Right? Do you have any wide predictions that you think like will be there? Like, would you have autonomous browsers talking to each other, autonomous voice agents? Like, how do you think about this, the overall state of technology 10 years from now?
Whoa, man, we've seen in the last 2 years the AI industry moves so fast. Like we don't even know what's going to happen in 2 months because lots of smart people are working on lots of very interesting things. But I think one of the interesting things about being in a decision making role at a company is that you get to have this sort of like forward thinking moment where you say, hey, what's my roadmap for the next 3 months, and how do I make sure that whatever I'm building stays relevant in the next 3 months? And I think we will get to a point where we would see vertical AI enabled businesses where the entire stack of the business is completely run by AI agents. I think we'll get to a point where, take for instance, I don't know, like insurance, we will see like an AI insurance run agency where it's all just AI agents just doing all the sort of like insurance guidelines on all the claim specifications and doing all of the, handling the claims and then doing all the decisioning. So I don't know yet what is going to happen on the technology side. And frankly, I might not be as qualified to say, hey, this is what we would see with like browser use agents and all of these things. I think we're trying to evolve with the technology landscape, but what I do have is a vision for how work will get done in enterprises, and whatever technology like gets us there. I think there would be a decent amount of like on-device models to make like things cheaper to use. I think there has to be some sort of maybe a new infra for how LLMs fundamentally work for, let's say, the software to be faster. But generally, I think we will see like vertical businesses that are fully AI operated.
Okay. Like one of the other things was like, what was that one time that, like, one thing that, you know, like that made you feel like, oh, like this technology is fundamentally going to be as interesting as the future, as interesting as like internet. Like this is like the future. Like what was that moment? Like if you can remember, because there's a lot that so many of us are betting on, right? Like in terms of the where our energy and direction. So what's that moment for you? Like,
Yeah. I've had a few moments in AI that have been this few enlightenment moments where I'm deeply impressed by a piece of technology. And I think you've had a lot of those. But, you know, the birth of ChatGPT was one, and I think for like billions of people, it's one. The first time I used VO3 was another moment where I give a prompt and I just saw this photorealistic animated image and the video come up with like audio all overlaid on it. And I have seen a few things where, especially in the business that we work in, whereas something was down, like one of our document processors was down. And an underwriter at a company that we worked at sent me an email like a few minutes after it was down. I was like, hey, this thing is down. Can you guys really fix it? It's urgent. And that moment was like, wow, this is something that he cannot do his work without. I mean, he can, but it really helps him do his work. It goes down a few minutes. It's like, hey, can you get this shit up, please? And so that was like the third moment. So I've had three of those. I've had one with ChatGPT, one with VO3, and one where our documents processor was down and an underwriter just like reached out minutes after it was down. Say, hey, can you get this thing back up for me? So those have been my three moments that I've had in the industry. I'm like, oh my God, this is gonna really change how work gets done.
That's interesting. So one of the last interesting questions. I'm trying to cater for a range of audience, and some, I'm hoping that some engineering leaders are also listening to this. My question is, let's say you're in charge of a big division of an engineer, at a big engineering company which has been doing quite well, and now you have this new technology at disposal, but you have a lot of legacy code, a lot of legacy systems, a lot of integration problems. We've also seen this personally at Addy. So how would you encourage some of these companies to think? Because a lot of companies are they're putting this roadblock between these systems, and there's a lot of skepticism around like opening the doors to these systems and allowing APIs and whatnot. Like, what's your overall take when it comes to like running like an organization, and how should I think about this?
Yeah, well, I think that's a three-part question. So one I think is like thinking about how do you open up legacy systems and to AI tools. One is how do you evolve legacy systems when it's a critical dependency? And then the third one is more of a question of how do you gain the what's the word I'm looking for? How do you gain the courage to sort of like let go of legacy systems? And I'll start with the last one. I think there has to be some sort of like Elon approach. Like Elon has this framework where he says, if you're not adding things back into the system, then you're clearly not deleting enough, which means you have to be deleting as much of a legacy thing as possible that maybe people don't use as much or it's not providing much like enterprise value. And then if like you're not adding things back and you're clearly not deleting enough. So one of the things that we've done at Addy is we've deleted, quote unquote, we didn't delete the code base, but we just removed it from the platform, a couple of features. And we're quick to say, hey, this thing is not doing well. We have to just like let go of this and focus. And in the last month, we've actually focused on a core feature on the platform that is doing really well. That's not quite legacy. So I think like engineering leaders would need to have the courage to just say, hey, I'm just going to delete this thing and then see if people complain and then I add it back, is having that Elon courage. And then the two other ones is like, how do you open legacy systems to how do you open legacy systems to the AI, legacy systems to AI? I have a firm belief that these legacy systems will not change. The internet is not going to change. There's still going to be some sort of COBOL thing that runs like every day when if you have like low cash mode on your bank, there's going to be some COBOL program that goes through all of the bank accounts and then check if the account is below $100 and then send this email. I think with those systems, we just have to use some sort of like AI agents that can use those systems in a sense that sometimes I think browser use would be huge, but then it requires a lot of one thing that I think is a lot of delegation, whereas you're not letting the browser use agent just use the system, or quote unquote, it wouldn't have to be a browser use agent, like an app use agent or a system use agent. Whereas, hey, humans are doing it this way today. The system's still going to exist, but the AI agent will then do the work. Whereas the delegation of like controlled access in a sense that, hey, the agent acts on behalf of a particular person who's accessing it. So I think that's one way you open up. And I forget the third thing, but maybe it's like related to this. But businesses will just have to die if they don't allow AI systems to integrate. We will start to see this a lot where newer AI startups will become the platform where work gets done, and businesses that don't open up their platform to allow AI systems to interact with it will just have to die because if they cannot innovate fast enough and build their own AI, they just have to let other AIs interact with it. And Apple has created this great app store model. It works really well. It's probably one of the best business models out there. Just be the platform. As the world's not going to go back to where it was like 3 years ago. Like existing businesses, just like you can just be the platform, be the system of record, and just let these AI apps that like integrate because there's a new breed of engineers that are being bred that only know AI as the platform to build. So they're only going to build AI agents. They're not going to build AI apps. So if there's like systems where they don't allow AI agents to communicate, those systems are frankly just going to die. And I think that's just a hard truth that we have to be very clear about.
Yeah, that kind of is very insightful, having, it's something that I think a lot of leaders and like at different teams are probably also thinking about. So it's a good pointer there. Thanks for that. But yeah, otherwise, I think we've covered a lot of ground and we're getting toward the end of the podcast. So one last question that, I have for you is there a question you'd like to leave for the next guest that's coming on the pod? Like,
I would like, think about this for a second. So it's for an audience of engineering leaders, like forward deployed and software engineers, forward deployed engineers, like an engineering podcast. I would say, what do you think needs to change in the engineering world that would enable AI agents to have 99% accuracy in getting tasks done?
okay. All right. So if you could repeat that one more time.
Yeah. What do you think needs to change in the engineering world that would enable AI agents to have 99% accuracy in getting tasks done?
Okay, 99% accuracy in getting the tasks done. That is an interesting one. Yeah, so we'll definitely pass on this one to the next person and see how it goes. But yeah, otherwise, I think we'll call it an end. Thanks a lot, Michael, for joining me on the podcast. I'm sure I'll have you again at some point on the podcast. But so far, thanks for all the insights, and I'm hoping that this will help other engineers and leaders in this space to make certain decisions or the things that they could think about. So, yeah, thanks.
Thanks,
Bye.
bro, for having me.
No problem. Bye.